Hello students, welcome back to my channel. In this video, we will be continuing chapter 11 data communications from your class 12 NCERT book for computer science. And today the topic that we are studying is the capacity of a communication medium. So as we studied in the previous video, that communication mediums are the actual path through which the message or the data gets transferred from the sender to the receiver. Okay. Now, to understand the capacity of a communication medium, we first need to understand what we actually mean by capacity. So capacity means the maximum amount of information or traffic or data that can be carried by that link, by that communication medium. Okay. So, for example, if I say you have a water pipe, if the water pipe is thin, then the amount of water coming out of that pipe in 1 second will be less as compared to a water pipe that is very thick. Okay, so the water pipe are different on the basis of their capacity and their thickness, how they are built. So here also, when we are sending data and communicating, then we need to take care that our communication medium or our channel, how much data can it carry, what is the capacity of that channel, what is the maximum amount of data that can be carried by that channel in a given amount of time. Okay, and to understand the capacity of a channel, we first need to understand the concept of frequency. So the word frequency comes from the word frequent. Frequent means how often you are doing something. So for example, if you are visiting temple twice a week, your frequency of visiting the temple is twice a week. Okay. So frequency in terms of data communication means the number of oscillations that are made by a wave or an analog signal per second. So we all know that when we transmit data, computers or digital devices generally understand data in terms of zeros and ones, that means binary bits. But to transmit data over a medium, we need to put that data or transmit that data using analog signals. Okay. Now these signals are in the form of waves, and these waves can either be something like this. So this is also a wave, this is also an analog signal, and this is also an analog signal. Okay, so what is the difference between these two? As you can see, the frequency, that means the number of times this wave is going from top to bottom then to top in a given amount of time, is different for both the cases. This wave has more oscillations per second. Okay, and if I say this particular wave has 5 oscillations per second and this particular wave has 2 oscillations per second, then its frequency would be higher. Okay, and if a wave has a higher frequency, it will be able to carry more amount of data with each frequency, with each oscillation. Okay, so oscillation of a wave governs its frequency, and the unit in which we measure the frequency is known as hertz. Okay, now we use the concept of frequency in bandwidth. Now bandwidth is the difference between the maximum frequency and the minimum frequency that is supported by a channel. So if we have a transmission medium and that transmission medium can support frequencies within a given particular range, say from 90 Hertz to 100 Hertz, then the bandwidth of this channel is 100 minus 90 Hertz. Okay, so this is the minimum frequency that can be supported by this channel, and by frequency we mean this channel will be able to transmit a signal that will have 90 oscillations per second, and a maximum frequency can be of 100 Hertz, which means it will have 100 oscillations per second. Now higher the bandwidth, higher will be the capacity of the channel, And since bandwidth is also the difference between two frequency values, that means 100 Hertz minus 90 Hertz in this case, so its unit is also the same unit as frequency, which is Hertz. Okay. Now usually the frequency that we use for communication is very high, and we need higher and bigger values as compared to Hertz. So 1000 Hertz equal to 1 kilohertz and 1000 kilohertz equal to 1 megahertz. Okay, so these two terms you need to know because they will be used in your numericals also for conversions. So 1000 Hertz equal to 1 kilohertz and 1000 kilohertz equal to 1 megahertz. Okay, so capacity of a channel is defined by two things. One of them is bandwidth and the other is data transfer rate. So before understanding data transfer rate, just keep in mind that bandwidth is the difference between the two frequencies, the maximum and the minimum frequency that can be supported by a channel, and higher the bandwidth, higher is the capacity of the communication medium to carry data or to transmit information. Okay, so coming to the data transfer rate. Now, as I said, data, when it is transmitted over a channel, it is actually transmitted in the form of signals, which are analog signal as the waves that I draw in the previous slide. And these signals contain bits, and these bits are actually the message that we are sending. So bandwidth tells us how much data we can send, and data transfer rate is kind of the speed of data in which we can send. Okay, so the number of bits that can be sent from the sender to the receiver in 1 second is the data transfer rate. So if you can send 100 bits per second, your data transfer rate would be 100 BPS. BPS stands for bits per second. And if you can send 1000 bits per second, your data transfer rate would be 1000 BPS. Or if you want to write in terms of kilo BPS, you can do that conversion also. 1 kilo BPS or 1 kbps is equal to 2 raised to the power 10 BPS. 1 mega BPS equal to 2 raised to power 20 BPS, and 2 raised to power 10 is 1024, 2 raised to power 20 is 1024 kilo BPS. Okay, and there is also the term GPPS, which is 1 gigabits per second, which is equal to 1024 megabits per second or 2 raised to power 30 BPS. Okay, so these are the two terms that define the capacity of a channel. Okay, now let's solve a quick numerical that is given in your book as well. So the question says, a user wants to upload a text document at the rate of 10 pages per second. What will be the required data rate of a channel? So we want to know what should be the desired channel, the desired data rate at which we should transmit so that we can send the information at 10 pages per second, per 20 second. So it is also given that one page contains 1600 characters and each character is of 8 bits. So basically one page, okay, let's write it down. One page contains 1600 characters, but we'll have to convert these characters into bits because data will be transmitted in terms of bits. So 1600 into 8 will give you the number of bits that are contained in one page. Now we have 10 such pages. So 10 pages will contain 1600 into 8 into 10 total number of bits. Okay, so these were the number of bits that were present in one page, and when I multiply by 10, these are the number of bits that are present in 10 pages. Now I have to transmit these many bits in 20 seconds. So how will I calculate the data transfer rate? The data transfer rate would be the number of bits that I have to transmit. These are the number of bits, that means the characters and the content present in 10 pages, and in how many seconds I have to transmit? I have to do that in 20 seconds. So my total value would be 1600 into 8 into 10 divided by 20, and the final would be 6400 bps, which is 6.25 kilo bps. So how did you convert from 6400 to 6.25? You need to divide it by 1024, because as we studied, 1 kbps is equal to 1024 bps. So if you want to convert, you can convert it, otherwise you can keep it as 6400 bps also if not asked in the question. Okay, so these were the two important topics that we covered today: the data transfer rate and the bandwidth of a channel. Okay, so these are the two ways of measuring the capacity. That is all for today's video. I hope you have understood this concept. Thank you for watching. Till we meet in the next video. Mind your exam.